I'm Carl Anthony, Managing Editor for AutoVision News, and this is AutoSens Insights. We're speaking today with Mike Walters. He is the Vice President of Product Management for FLIR's far infrared and machine vision cameras. And Mike, it's great to see you again, and welcome back to AutoSens.
Thanks, Carl. It's great to be here. A little different this year, but it's great that we can all get together and talk about the recent advances in autonomous vehicles.
Indeed. And Mike, I know you have been busy with FLIR. I know you've done some work with VSI Labs. It's all very exciting stuff. We want to get to that and we want to cover that. But first, to start, for people that may not be familiar with FLIR and what you do as a company, can you give us an overview of FLIR and tell us a little bit about the company just to get us started?
Sure. FLIR is the market leader in long-wave infrared, far infrared, or thermal camera technologies. We're a public company. We have around $2 billion in annual revenue and well over 3,000 employees worldwide. We're extremely vertically integrated, which means we design our own sensors, optics, image processing, assemble and test our own cameras. And this, in practice, lets us customize our solutions to meet specific customer needs, like in the automotive space. FLIR's been helping to make automobiles safer for over 15 years and has delivered almost 1 million thermal cameras into driver-enhanced night vision systems during that time.
So Mike, let's talk about that. Thermal cameras and the automotive industry. So I think the big question then is, can thermal cameras make vehicles safer? What are your thoughts on that?
We at FLIR certainly believe that thermal cameras can make cars safer in three primary ways. A thermal camera sees heat and not light. So we're able to see in absolute darkness and greatly improve the perception of a vehicle in absolute darkness. Also, we're able to see in very high contrast scenes that would blind your eyes, typically like driving into the rising or setting sun or oncoming headlights. Those scenes impair visible cameras as well. And finally, we're able to see in many types of bad weather like fog or rain, again, improving the vehicle perception in these difficult situations and complementing other sensors on the vehicle.
Now, Mike, you have done a tremendous amount of work in this area, most recently with VSI Labs, with some of their cross-country drives to evaluate data and to evaluate ADAS systems. Tell us a little bit about the work you've done with VSI Labs and then how that partnership came together.
With VSI Labs, we've been very fortunate to really prove what thermal cameras can do to improve automatic emergency braking. So last fall, we presented some preliminary results. We went with VSI Labs to the American Center for Mobility, and we used a thermal camera and radar fused system to show how a thermal camera fused radar system could outperform many of the current vehicles on the road in terms of their automatic emergency braking. That was very preliminary results. And so recently in July, we went back to the American Center for Mobility and expanded our testing. We used this time a fused thermal, visible, and radar system. And we tested automatic emergency braking in the standard NCAP scenarios, new car assessment program scenarios. And then we added some additional tests we call gap tests. And the gap tests basically mimic real world situations that are a problem for automatic emergency braking. And we showed that, again, the fused thermal visible radar system was able to outperform existing vehicles on the road in those situations. The gap tests were things like exiting a tunnel into the sunrise. So the typical AEB system using a visible and radar is a bit blinded and can't see a pedestrian. We were able to stop successfully there. We tested at nighttime with adult and child pedestrians, crossing in front of the vehicle in absolute darkness. And again, the fuse system outperformed the current systems. And last, another gap test we performed was looking in a daytime scenario with a pedestrian whose clothing blended with the background crossing in front of the vehicle. And again, the fuse thermal radar visible system outperformed existing vehicles on the road.
Right. So Mike, you've done these preliminary tests, then you went back to the American Center for Mobility, did another series of tests. So with these recent AEB testing and the results, what would you say are some of the key takeaways after you studied all of the testing and you looked at the results? What are the key takeaways here?
I think the real key takeaway is that thermal cameras complement the existing sensors on a vehicle, and that we've demonstrated that you can absolutely have an improved automatic emergency braking system using a thermal camera as part of the vehicle sensor suite.
Right. And Mike, it seems like now, just where the industry is at in terms of self-driving cars, this is a great time to test and to implement technology like thermal cameras. Maybe we weren't thinking about thermal cameras a few years ago or 5 or 10 years ago, but now we are. We have this body of research. We have this data that shows that it would be a good investment. So what are your thoughts going forward? Is this a good time for ADAS developers and automakers to invest in thermal cameras?
This is absolutely a good time. And we've been just very pleased with the progress we've seen. In fact, FLIR over the last year has announced 3 major wins in this space. One OEM win for conventional vehicles, and then 2 autonomous vehicle robo-taxi wins. So we've seen automakers and autonomous vehicle developers go from evaluating far infrared cameras to actually beginning to deploy them in their fleets and in their vehicles. So it's been a very exciting time. I think far infrared cameras have established themselves as part of the ADAS and autonomous vehicle sensor suite. And I'd really recommend anybody working in the ADAS or autonomous vehicle space to give us a call and consider a far infrared camera as part of their sensor suite.
Now, Mike, in the past, when we have talked at AutoSens, you've spoken about the previous experience the previous experience that FLIR has that you have brought to the automotive industry. So you have this body of work, product line, research. You have a lot of experience in other industries, and then you've brought that into automotive and you have leveraged those strengths. So can you tell us a little bit about how FLIR got involved in the automotive industry, and then what strengths that you're bringing to the automotive industry that are unique to FLIR?
Sure. FLIR got involved in the automotive space really before we were FLIR. We were a much smaller company, Indigo, and we were kind of pulled into the automotive space way back in the early 2000s after the first vehicle adopted a thermal camera, and the industry was looking for ways to make it more manufacturable. At that point, since we were a much smaller company, we were partnered with Autoliv, a tier 1, now Veoneer, and they remain our preferred tier 1 supplier, and we have a very close and continuing partnership with Veoneer. This partnership, together with Veoneer, we've worked together over the last 15 years, delivering thermal cameras to a variety of vehicles as an option. as a part of this driver enhanced night vision. So during that time, we developed or delivered almost 1 million thermal cameras to the automotive space. We leveraged all that vertical integration capability and the capability of controlling our manufacturing operations, and have really learned the automotive industry requirements over that period of time. And Veoneer was a very good partner in helping us to mature our design and manufacturing processes over this time. So we continue that partnership, but we're starting to add today deep investments in functional safety, for example, so that our cameras will be suitable for application in autonomous vehicle and ADAS applications where the camera is really being used to control the vehicle operation.
Right. That's what I was trying to say, Mike. You put it much more succinctly and much more efficiently than I did, but wanted to just say that there is a long history with FLIR of developing thermal cameras. You've been doing this a long time.
Right, right. We've been at it over 40 years as a company, and like I mentioned before, exceptionally vertically integrated. So we really have controls over all of the knobs in the system, the sensor itself, the image processing, and the optics, the manufacturing operation. So it's this scale, being the $2 billion a year public company that we are. It's the history and manufacturing experience. It's really this design and manufacturing end-to-end control of everything we do that I think FLIR really brings to the automotive space.
Right. So Mike, let's go back then just for a second to the testing that you did here in Michigan, some of the gap testing. We're talking about everyday driving situations. So I'm driving my car, I go into a tunnel, I exit the tunnel, there's a bright burst of light. I mean, these are very common driving scenarios. Pedestrians wearing different clothing as seasons change, right, from summer to winter. So when you look at that and you look at what thermal cameras can do, long term, why is this important as an industry for us to invest in?
I think it's important, simply put, from a safety perspective. A sensor suite for automatic emergency braking, ADAS, or autonomous vehicles needs to be extremely robust. And I think thermal cameras fill a very important gap in the current sensing capabilities. So we fill that gap most notably in absolute darkness, since we're able to see and perceive the environment very much like a visible camera in absolute darkness. We're able to see details, mainly people and other living things that you most don't want to hit, very well in absolute darkness. But like the scenario, the gap test we did with the pedestrian's clothing that blended with the background, looking for a different signal, looking for the thermal profile, the heat emitted from a pedestrian, gives us a complementary sensing capability that's just so critical to achieve the safety levels that are needed in the automotive space.
Right. And Mike, this is what I think is, and every time we talk, I think this is one of the neatest parts about FLIR, is that you're able to take all of this history, which we talked about from the early 2000s, but this long history that FLIR has with thermal cameras and other machine vision cameras, and then you're able to look at very specific use cases. Okay, I'm going to exit a tunnel and there's going to be a burst of light, or I'm going to drive and then I'm going to encounter a pedestrian that has clothing on that blends in with the background that maybe the human eye just doesn't immediately see. And those are very real world situations. But I think it's very interesting that you can take that history and all of that technology and apply it to these very important use cases that drivers like myself or anybody else could easily encounter every day.
Right, and something important that we're adding to that history that I should mention is our CTO team has been doing extensive work in machine learning and neural networks. And we put that very much to use in the recent testing that we did at the American Center for Mobility. So not only were we adding a thermal camera to this vehicle sensor suite, but we were actually using FLIR developed and FLIR trained neural networks to identify objects in the scene and actually generate the signal that was used in the drive-by-wire vehicle from VSI to cause the vehicle to brake. So that machine learning work that we've developed, an entire infrastructure that we have available at FLIR for basically putting together a portfolio of thermal images, training the neural network, testing the neural network, and feeding back corner cases to improve the neural network is really an exciting part of our recent development work that we're bringing to the automotive space as well.
Mike, as always, it is a pleasure to chat with you and to get caught up. In the last couple of minutes that we have, do you have anything to add? Is there anything that we have missed? Is there anything you'd like to summarize again? Anything you'd like to say for future announcements? Is there anything you'd like to add?
Just to sum it up, I think we've put thermal, visible, and radar fused neural network system to the test. That was a neural network, as I just mentioned, developed by FLIR and applied to the VSI vehicle. I encourage everyone who's attending AutoSens to join Phil Magny and myself for a talk on this subject and to learn more details. And if you're out there working on a ADAS system or an autonomous vehicle, please reach out to us, and we'll be happy to provide even more detail on how FLIR can support you and make your vehicle safer.
Yeah, that's excellent, Mike. And I'm looking forward to that presentation and that talk that you have planned with Phil Magny. So I'll plan to tune into that. From all of us here at AutoSens, we want to wish you good luck going forward, and we'll look forward to speaking with you again at a future conference here down the road.
Sounds great. Thanks so much.
For more great content from AutoSens, visit our hub or our YouTube channel. Just search AutoSens.